Now I would like to present our research towards optimizing the use of knowledge frontiers, distributing nature categories along citation paths. In our presentation, we are going to talk about articles' contribution to knowledge or disciplines or research category. To each paper, we assign the category vector, which components show the contribution of this article to different disciplines. Then we define the referencing relation, its composition, and finally the transitive closure of relations. Next, we present two examples and finally show the category vectors of nature categories of articles. At the end, we present some conclusions. The principal source of spreading knowledge is papers. The paper's contribution to the development of knowledge categories is not only by their publication, but also by the fact of being cited. Bibliometricians have prepared only a few measures for the influence of a network of citations, especially considering the knowledge divided into disciplines. The article proposes the method of calculating the category vectors presenting the article's contribution to the nature categories, with the transition closure showing the whole citation matrix of citations. The level of the article's contribution to the science, considering its citations network, is estimated, and transitive closure for the one article's network is presented. We estimate the level of the development of each category using the value from the interval 0, 1. Each article and each of its referencing papers increases the category level by the contribution unit A. Each citation of the article belongs to the citation tree and increases its contribution to all categories. The paper's contribution to the knowledge, divided into categories, is represented by the category vector. The optimistic fuzzy aggregation norm is applied to calculate the values of the category vector of the considered article. We assume that after publication, the article contributes to the category and it contributes the same value. Let A be the contribution unit and let us assume that A equals 0.1. For an article, we build the row vector called category vector of the level 0. Nature database divides knowledge into 14 categories. Thus, if the article is assigned to one of the categories, this component equals A. The others are zeros. We apply the optimistic fuzzy aggregation norm to accumulate values along paths in the citation tree. Let X be the space. Optimistic fuzzy aggregation norm is defined on the product of space X, and its values are values from the interval 0, 1. This function fulfills three conditions: border conditions, commutativity, and the optimism, which means that S of xy is greater than maximum of xy if x and y are not zeros. We use the function S of xy equals x plus y minus xy because of its simplicity for calculations. Let P denotes the set of articles. Articles A1 and A2 are in the relation R if A2 references directly A1. Relation R has the following properties. It is anti-reflexive because any article cannot reference itself. It is asymmetric because if article A1 references paper A2, then A2 cannot reference A1 because of the publication process. Relation R is generally not transitive because if article A2 references A1 and article A3 references A2, it is not necessary that A3 references A1. Let A1 be the root of the citation network. In this network, some articles cite A1 directly, some referenced articles cite A1, and so on. Since relation R is asymmetric, all possible paths are finite. Let n be the length of the longest path. Assume that A2 cites A1, and let n be the number 0, 1, or n. Let V1 and V2 be category vectors of the level n of articles A1 and A2 respectively. The components of the category vector of the level n+1 of parent A1 is defined using the optimistic fuzzy aggregation norm. Let X, Y, Z be spaces and let R and S be two relations. Then we can define the composition of the two relations R and S using the presented formula. Let R0 be equal to R. Then R0 is called the level 0 contribution matrix and is defined as follows. The first column's elements are the article ID and the second column is the reference article ID. Let R1 equals the composition of R0 with R0. Then A1 and A3 are in the relation R1 because there exists article A2 such that A1 is the relation R0 with A2 and A2 is the relation R0 with A3. Let n be natural number, then R0 equals R, Rn plus 1 equals the composition of R and Rn. Since R0 is R and for n, R to n plus 1 equals the composition of the relations R with R to n, we can define the transitive closure in the following way. R plus is the union of relation Rn. We showed that transitive closure is finite. Hence, we can define the space H, where P denotes the set of articles, R plus the transitive closure, and T is the set of category vectors. We present the simple citation tree. All articles in this citation tree are assigned to only 3 categories. So we reduce the contribution vector to only 5 components: contribution to biomedical research, health and physics, number of the nature category, and the year of publication. The first column of the table contains the article's ID. The second, the assigned category. The next one, category vectors, then citations. The tables show the next levels of category vectors. Finally, the contribution of the article to biomedical research is 0.4, to physics 0.1, and to health 0.3, although it is assigned to the biomedical research. Here we can see the following matrices of the citation tree relations and its whole transitive closure. Here we present the category vectors of the publication of Keegan from the Nature database. We can see 6 levels of citations. The category vectors of Keegan article show the contribution of this paper into many Nature categories, although it is assigned to only one, clinical medicine category. We can calculate category vectors not only for single papers, but also for the whole categories. Here we can see the diagrams of average contribution of papers from 3 categories: arts, biomedical research, and mathematics. Assigning to each paper the identical quantity of knowledge and calculating the contribution to science lets us estimate the contribution to science level of the article by including the network of referencing articles. Since knowledge is divided into disciplines and research areas, it is possible to develop vectors whose components present the levels of different categories contributions. Rankings based on category vectors and citations counts are significantly different. Citation counts are rather relative bibliometric measures since they calculate only one value related to the chosen discipline. Category vectors depend on category dissemination while the given article is referenced. The category growth shows the impact on citation weight, which has been changing over time during analyzing the data. The next conclusion appears to be datable. Citations are not a good measure obtained eternal and cannot be assumed an absolute and stable measure of the scientific impacts of the article. Since the knowledge dissemination runs from the root to the leaves, then the category vectors can be assigned in the opposite direction to time, from the leaves to the root. All nodes but leaves inherit non-linearly the knowledge through citations along citation paths. Then each new citation causes quanta of knowledge categories to be observed by all three nodes, and the root gets the most. Hence, with the bigger tree, longer and wider citation paths, the root article has a stronger impact in a wider variety of categories. Therefore, researchers' scientific achievements evaluation cannot be confused with the overall contribution of a particular discipline of the science universe. The application of optimistic fuzzy aggregation norms can help evaluate researchers. The deeper the citation tree, the largest contribution the root and all intermediate nodes received, even if the root has got only one highly cited publication. Thank you for your attention.